Okay, consider the table below and answer the questions which follow. So you have got the number of workers, the column for the number of workers, the column for the total product, and you have the column for the marginal product. So what you are supposed to do is to consider the table and answer the questions. The first question says, without using the numbers above, can you draw the total product curve and explain its stages? You are not using the numbers above. Okay. So how do you draw the total product curve without considering the numbers above? So the total product curve is like this. Okay. This side on the vertical axis, you have total product, the total product itself. Then on the horizontal axis, you have output. Okay. So the total product, it starts from 0, it moves like that, it reaches the maximum, and it starts falling like that. That's the total product. So from 0 here, you can put the units or output as 0, 1, 2, 3, and 4 here, like that. So what is happening is that you need to explain the stages in the, you explain the stages, okay? The total product has got 3 stages. Yeah, it has got 3 stages. So you see there is, let me draw this line like this. There is a point from 0 here, from 0 output, okay? You know, when you look at the slope from 0 up to somewhere here, 1.2, the slope of the line is not very sharp, okay? This is the first stage of production. Then there is a stage at which the total product curve, this one, TP curve, that's the total product curve, starts the slope starts increasing. When the slope starts increasing, it means that the line, because we know that the slope is like this, right? When the slope becomes that sharp, then that's the second stage, up to a point where total product is maximum here. It's the second stage. Then the later stage, which is the third stage, is the stage after maximum, after total product is maximum. Okay, let me explain like this. Production has got stages, okay? It has got the stages. So in the first stage, there is the first stage here. This is our first stage, our second stage, and our third stage. So what is happening in the first stage is that output is increasing. Output is this one on the axis. Output is increasing, but the total product, okay, the total product we get is not increasing at a faster rate. You're seeing this. The way how the total product, this curve is increasing from 0 up to somewhere 1 here, is not very sharp. It's not very fast. Okay. So what happens is that this is the first stage of a business. When you are starting the business, you incur there are a lot of costs, in short, that you have to incur. So as you're trying to set up as a business, what will happen is that, yeah, you're quite all right. You might produce a lot of output. The output may be increasing, but the problem would be what you get in terms of the production. The production might not be increasing at a faster rate. Why? Because at this stage, you have a lot of cost to incur as you are starting the business. Is that okay? That's the first stage. Then the second stage is when this curve now starts increasing at a faster rate. This is a stage in business when at least you are able to incur most of the costs. You are able to incur most of the costs. So what will happen is that as output now will be increasing, you find that even total product is increasing at a faster rate towards the what? Towards the maximum point here.
Okay.
You're following, right?
Yes,
yeah.
sir.
Towards the maximum point here. So this is the second stage. The stage from the point at which total product starts increasing at a faster rate up to the maximum out up to the maximum of total product, when total product is maximum at that point. Yeah, that's the second stage. Then the third stage is the point at which, this is the point after the maximum total product, where total product starts what? Decreasing. So there is again some stage in the business. Yeah, due to diseconomies of scale, diseconomies, you find that as you grow big as a business, sometimes there will be a point where even if you increase the output, what will happen is that now, as you increase the output, even the cost will start increasing as well. Okay? So you find that now the total product will start decreasing after that point. So that's why you find that at this stage, even if you produce, you increase production, you keep on producing and producing, then you just end up starting making what? Making losses. Okay?
Mm-hmm. Yes,
The
sir.
business, the easiest one we could give you, the practical example would be of when you are starting a business of maybe you are selling some things. Okay? As you are starting selling, in the beginning, at the first stage of production, yeah, you can be increasing in terms of the output, in terms of what you are producing, but you find that what you gain is not increasing at a faster rate because there are a lot of issues that you have to handle at the first stage of the business, right? Yeah.
Yes.
Then afterwards, you are selling, there is that point whereby now you increase the output. As you increase output, the business has been known. Even the people who come to buy your products have increased in number. So you find that now the product, the total product is increasing at a faster rate. You increase output, even total product is increasing up to a certain point. This certain point here, let's assume this is 2.5. When you reach at this level of output, this is a level whereby even if you produce as a firm, you just reach at a point whereby once you produce, all what you have produced will be bought, right? At this point, whatever you have produced will be bought. More like what you supply is now equal to demand at the point of sachet. You can't, the total product will no longer go beyond. Okay? It will no longer go beyond. It is no longer increasing when it reaches the maximum. So at that point, you reach at a point whereby the output is equal to the maximum what? To the maximum total product. Then afterwards, there'll be a point whereby if you keep on producing now, you have a lot of inventory. Okay. You have a lot of inventory because people will be coming to buy what they can manage to buy, they buy. Then the rest you will start keeping now as what? As inventory. You're following, right? As you keep a lot of things as inventory, you need the storage. You need the storage. So that storage, you have to incur costs. Those are storage costs. You'll have to incur costs. Maybe you have to build more warehouses, more storage space so that you can at least be able to keep those things that you keep on producing. So even as a firm, you don't just keep on producing. You reach at a point whereby you are also avoiding having a lot of inventories. You just produce how much can be bought. Okay, maybe at least 1 week. Then from there, again, things should be able to finish. Also that you produce, then things are not finishing. Did you get that?
Yes, sir.
Rachel, did you get it? Or you don't want to speak? Or maybe you are in an environment that cannot allow you to speak. Are we together? Okay. We go to question number B. It says complete the table by filling in the figures for average product and marginal product. Okay, that's the second question you have, is to, we have to fill in, to complete this table. We fill in the average product and what? The average product and marginal product.
Marginal
Okay,
product. Yes, sir.
so the average product will be total products divided by what? By output, which is basically the number of workers. Yeah. This time
You
around, the
said
average product, total
average
product, average product. In
is
this
equal
case,
to
since you are dealing with the number of workers, it is average product of labor is equal total product of labor divided by output of labor. That is the number of workers, in short, the number of workers, the units of labor, right? So total product divided by the respective number of workers. That gives us the average product of labor. Clear?
sir. Just come again on that one.
Average product of, okay. I said the average product of labor in this case, yeah, shall be equal to total products, right? Total products divided by the number of workers. Since we are dealing with labor, units of labor or output, if you might want to put it like that, the units of labor, okay, which you usually call output. Okay, so that is how you get the average product of labor. This is the same version of looking at it, even when you are looking at the average product of capital, right? We are dealing with the two inputs that we use in production. There is the capital. We assume we are using capital and labor here. So the average product of labor shall be just found by saying total product of labor over the amount of labor that you have. Then the average product of capital, it shall be just the total product of capital divided by the units of capital that you have. That gives you the averages of the inputs. Is that okay?
Okay, sir.
Okay. If that is okay, then we can fill in this. Okay, before we fill in this one, let me comment also on marginal product. So with the marginal product of labor, because this is just general, it has to be specific. That marginal product of labor, marginal product of capital, like that, that's when it becomes full. So this, in this case, since we have the number of workers, we just assume it's a marginal product of labor. Yeah, that is being compared to. So with the marginal product of labor, yeah, marginal product of labor shall be total product, okay, total product of labor, of course, total minus total product 1 over output 2 minus output 1, like that. That gives us the marginal product of labor. Got it?
Okay. You said marginal product is equal to total product 2
yes,
minus total product 1
divided
over,
by
unit
yes,
of labor 2
yes,
minus unit
minus
of labor
1. Okay,
okay.
that's how you find it. Okay, just the same way how you find marginal cost, marginal utility, marginal revenue, if you remember something like that. The way how you are doing marginal utility, okay? Yeah, you find them in the same way.
Okay.
Hello?
Hello,
Yeah,
sir. I'm saying, I wanted to ask to say, is this the same way we find the marginal utility?
Yeah. The way how you find the marginal utility, marginal cost, marginal revenue, yeah, including this, it's just the same thing, okay? Marginal product, Wherever you find marginal, that's how you find the marginal. Okay?
Okay. Okay.
If that is okay, then we can move on and fill in the table for the product,
Yes.
for the average product, right?
Yes, sir.
How do we do it? I said it is the total product divided by what? By
Unit
the
of,
output, the unit of labor. Yeah.
yes, sir.
So we divide the first one, it shall be what? 10
10.
divided by 1, which shall be what? 10, right?
Yes, sir.
The next one shall be 25 divided by 2, which shall be what? 12.5, yeah?
12.5.
And the third one shall be 45 divided by 3, that gives us 15, yeah?
10.
And the 55 divided by 4, what do we get?
13.75.
13.
Yes, sir.
13.75, let's
5.
say 0.8. 5 into 60, that is 12, right?
Yes, sir.
And the 6 into 65 is how much?
Sir, you said 5 into?
5 into 6, like this. Then 62 into 66, 65. What do we get?
6 into 65.
Yeah.
We get 10.83.
10.83. Then the third one is
It goes on, sir. 10.833333. So we pick how
okay.
many?
Just one decimal place. So we say 10.8. The next one is 7 into 63, and it should be 9, right?
Yes, sir.
And the 8 into 58, 58 divided by 8. What do we get?
7.25.
7.25. Okay. 7.25, which should be 7.3, right? This is what we find as average product. Is there any question on the average product?
No, sir. So far, so good.
Okay. Let's find now the marginal product. The column for the marginal product. With the marginal product, we said total product 2 minus total product 1 over output 2 minus output 1, right? So
Yes,
we
sir.
shall say the first one, total product is equal to marginal product. They start at the same point because so it's 10 is equal to that 10, all right? Then the second one, you say 25 minus 10. This 25 here, which is total product 2, right? Minus 10
Yes,
over 2 minus 1, the output, this one and minus that. And what do we get? We
this
have
one will be 15.
15. Yeah, right, 15. Okay. Then we go to the third one, which shall be 45 minus 25 divided by 3 minus 2. What do we get?
We will get 20, sir.
We get 20 to 0. And then we go to 55 minus 45. 55 minus 45. So that is 55 minus 45 over 4 minus 3.
We get 10, sir.
We get 10.
Yes, sir.
And we go to 60 minus 55. That should give
We'll
us
have
5,
5.
right?
Yes, sir.
And then we go to 65 minus 6. Again is 5.
5.
Then we have 63 minus 65. This is negative,
We
right?
have, yes, sir. We have -2.
Negative 2. And the 58 minus the 63, it's negative what?
68 minus 50, 58.
58 minus 63, like this total product minus the previous one, over 8 minus 7.
58 minus
63.
58 minus 63 to give us
It's
negative
negative.
5.
Yes, negative 5. So basically, this is how you deal with with these figures. Okay.
Yes, sir.
So now this is true even from what you get from theory, because theory tells us that total marginal product always increases and increases up to a certain point, then it starts decreasing.
Yes, sir.
That is what we get from theory.
Yes, sir.
Yes. Yeah. So observe that marginal product is increasing and up to summer unit number 20, right? Up to
Yes, sir.
unit 3. Up to unit 3.
Mm.
Isn't it? From unit 1, 2 up to 3, marginal product is increasing. Then later on, that's what decreasing until it goes to the negative.
Mm.
Okay.
Yes, sir.
Yeah. Then if you observe the behavior now, with the behavior of average product as well. Average product as well, it starts small, it increases, and then it starts decreasing. But the rate at which average product is decreasing is not as fast as the marginal product. Are you able to analyze the numbers? Look
Yes,
at
sir.
how average product is moving. It reaches the highest it goes is 15 when marginal
Yes,
product
sir.
is at 20. So our marginal product is up. So then what will happen is that from 15, the average product starts what? Decreasing. 13.8, 12, 10.8, 9, and 7.3. But it is still positive. Now look at the way how fast the marginal product decreases. It moves at a very fast rate to a degree where it even goes to the negative when the average product is still a positive. Okay.
Yes, sir.
Any question? Hello.
Okay. So here, if they say they explain your answer, we give the same explanation here from giving.
Yes, it's valid, it's legal.
Okay, sir.
Yeah. So now, graphically, if you are to depict this graphically, you can see, and let me just combine all the curves now together. Because if you want, you can even plot these numbers, this output against the average product and the output against marginal product. You see the curves coming out like this. This is how they're going to come out. You can see that you can plot them, and the output is always on the horizontal axis. 0 output here. Okay. Then the total product upward. So you see that total product itself, it will go up, 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 and then it will start what? Falling, isn't it?
Yes, sir.
That's what I just explained. First of all, it moves like this, then it goes sharp like that, then it falls. Why should it? First of all, it doesn't increase at a faster rate. I said this is the first stage of production. Yeah. Then from there, it starts increasing up to the maximum. Now, look at how the average product is moving. It starts at the same point as well. It will start at the same point. The average product will be moving here under like this. This is how it will be. This is the average product curve. Now, the marginal product curve, check. The marginal product curve, this is the output. Then this is APL, average product. Then the marginal product will be like this. It will be up, it increases, then it crosses. You see now?
Then
How
it's just going down.
how does it go? it comes like this, it increases. This issue of drawing, it's hard, eh? It increases like this, then it crosses. You've seen, eh? It crosses up to, it goes to the negative. Immediately after total product, you find it comes down and until it goes into the negative. That's the marginal product of what? Of labor. This is how the graphs come out. Average product is never negative. Okay? It is never negative. It doesn't go to the negatives. It is actually asymptotic against the horizontal axis. It's asymptotic, meaning it comes closer and closer, but it doesn't just touch. Yeah, that's what it means to be asymptotic. Okay. This is the total product, average product, and the marginal product of labor. This is how you graph. And you can see that from this graph, even the numbers, this is how they are behaving. So that, right? For the marginal product, they first went up. They even went up more than what? More than for average product. Yes. So for marginal product, they went as far as 20. Then for this one, the average product, they were just somewhere at around 15. So marginal average product, then the marginal product, it goes first up and it quickly starts coming down until it goes even to the negative. Okay?
Okay.
Yeah. Any question? Yeah. So this is what is there. Any question? No one has a question. Assuming no one has a question, Basa, your explanation is clear. We are all understanding, and you can move on.
Yes, sir.
Basa is begging to move. This was the same table. If you have observed, this one, it was just basically the same table, right? This was the same table that we had. It was just cut anyways, because I had to capture this. This was a camera. This is a photo. It's not really a document on this one. So you had filled in already the, what's this? Marginal product. Marginal product was this side, right? And the average product here. You had filled in these. So now the questions were the same. Without using numbers, draw the total product. We did that already, right? Complete the table by filling in the figures. We did that already. And what is the maximum number of workers the firm should employ in order to produce where there are increasing returns to scale? Okay. Where there are increasing returns to scale. What is the maximum? What is the maximum number of workers? Yeah. So you just get the number of workers where output is the highest. Okay. Where the increasing returns to scale is found where total product is actually the maximum. Okay. Because the increasing returns to scale, yeah. For you to get the increasing returns to scale, you need where the curve is still what? Increasing, not when it is constant, right? So, yeah, when it is still increasing, the total product is still increasing. That's where you get the increasing returns to scale. So you get where total product is maximum, and you know here where a total product is maximum. Is maximum on 65, yeah? 65. That means the unit is what? It's 6 units, right? They have to produce it. They have to employ about 6 people for them to still in order to produce where there are increasing returns to scale. They have to employ as far up to 6. Beyond 6, check what happens after 6. They employ 7 workers now. Total product is starts decreasing again. So which means they're no longer getting much from the people they have employed. Challenge again. Okay.
Okay.
So
Yes,
as a human resource practitioner, those that might be doing human resource, please get to understand that it's not just about employing. Yeah, of course, the power to employ lies in your hand, but you don't just employ. You'll have to look at, okay, now we employ this person. How much benefit do we get, really? Are the benefits still increasing? Are we still getting the increasing returns to scale, which is the contribution of those inputs? Are we still getting positive returns? Because you can't just keep on employing and employing. You employ up to a certain level whereby you see that, okay, now every worker at this point will be doing the maximum possible. Everyone will be contributing almost, if possible, equal inputs. Then at that point, it's okay. If you employ too much now, you find that the workers now, others will even start standing at the place of work, sitting, they have nothing to do. You understand? That's a problem. You don't need that as a human resource practitioner. So you produce only where when the marginal product is still positive, okay? When the marginal product is still positive. Yeah, when you're getting much. So beyond that point, then please, we do not employ. Okay?
Okay.
What is the maximum number of workers the firm should employ in order to produce where there are decreasing returns to scale? Every point after the maximum, the decreasing returns to scale are found here, where they are after the maximum point, which means it can be what? 7, 8, right? Should you employ 7 people, then you get the returns that you get at decreasing. Okay?
Okay.
Hello.
So the maximum number of workers that you should employ when a firm is, when they produce what? In order to produce where they are decreasing returns. So
yeah, where they are decreasing.
Why not 8, sir?
Yeah, you can still pick 80. It's still decreasing. Yeah. So the maximum number of workers the firm should employ in order to produce where there are decreasing returns to scale. The decreasing returns to scale starts from 7.
Okay.
Up to 8. It's decreasing. The curve is decreasing after the maximum. That's what we showed graphically, right?
Yes, sir.
Yes. So either of the two.
Okay. So you just pick one. You can't pick both.
No, you can write one.
You can't say 7 to 8.
7 to 8. No, it's not a range. It's a number. So you.
It's just the number. Okay.
Yeah.
Okay, sir.
Okay. Explain why firms are expected to produce where there are decreasing returns to scale. Why do we expect the firms to produce where there are decreasing returns to scale in the real world? We're talking about the issue of the real world now. In the real world, we have said that yeah, firms should not produce where they are what, where they are decreasing returns to scale, isn't it? But in the real world, you find that the firms produce where they are decreasing returns to scale. Why? Why the large firms do that? Hello.
I'm not sure why they don't do that. Why they do that?
Okay. So what is happening is that the challenge here is on determining exactly where the firm. This is just theoretical that you cannot really know exactly the point where you will get the maximum output, especially from labor. You understand? You can't really know exactly. Okay. It's very difficult to tell exactly that, okay, now when we employ such a number of people, we'll be getting equal contribution, or when you employ such a kind of labor. That's from the practical point of view. Then what happens in the real world is that, number one, it is difficult to determine the level of our output, or the number of the units of an input. In this respect, we are talking about labor. It's very difficult to determine the exact one that gives us only the maximum. You cannot usually manage. Yeah, in the practical way now. That's the real world. That's why we have brought in the real world scenario. Then the other thing is we have the diseconomies of scale. Okay, it is due to the diseconomies of scale. We know the diseconomies of scale. Okay, the diseconomies of scale are when the economies of scale are advantages that a firm gets because of expansion, right? The firm enjoys some benefits due to expansion. Then those are economies of scale anyway. But the diseconomies of scale is the opposite, like the disadvantages that come as a result of growth. Okay. What happens is that as the firm grows in the real world, the costs, there will be a point again when the total cost will start increasing. You're following, right? I explained this when I was talking about the total product as well. What will happen is that in the first stage, of course, you can have a lot of costs to incur. That's first stage. Third stage, you have your costs lower now. Your costs are lower, you're producing. But as you are growing again, you find that again your costs will start increasing as compared to what you get. Then your revenue or your output will start, the product will start going down. Okay, will start going down. That's the time when we have the negative or decreasing returns to scale. Yeah, whereby you employ more, right? You employ more, but as you employ more and more, what will happen is that what you get, the return from those people that you are employing, is that it's little, it's decreasing and decreasing. That's the point. Okay. This can be as a result of the diminishing returns to scale. Yeah, diminishing returns to scale. The law of diminishing returns to scale, it states there is what we call the law of diminishing returns to scale. Right? The diminishing returns to scale, the law states that as you increase the employment of an input, either labor or capital, what will happen is that now the additional inputs that you have employed will contribute less than what the previous unit contributed. You get that? I was giving an example of whereby you start employing workers. When you just still have only one worker, that worker at the place of work is the one who is doing almost everything. Who work hard, you get everything possible, like the maximum possible from their contribution. You're following, right? Then as you employ the second person, I'm trying to explain the law of diminishing returns to scale. As you employ the second person, what will happen is that this person who is coming the second time will work hard, of course, but not as hard as the first one. Yes, you're following? Even the first one will no longer be working as hard as he was working at first. As you employ the third again, the third will not work as hard as the second one. Like it's just reducing and reducing. The contribution is reducing and reducing. So this is what we are trying to bring in when you talk about the concept of the diminishing returns to scale. Okay. Is that okay? Yeah, this was fair, but sir, we understood. And now we can look at the question number 4. All these questions that we have done, they are coming from the one topic, which is the firm theory. We're looking at production. The previous question was talking about production, yeah? Just production function, if you want. So now let's dive a little bit into costs. We study costs. This is the last question, okay? I know you might be tired, but please be stronger a bit. We do costs. Let's do costs. You'll be okay. So that we can cover the cost theory as well. Yeah, using this question. Yeah. Okay. You have to pay attention because I'm teaching almost the whole topic using one question. So I say a lot of things on one question because I'm teaching. Obviously, when you'll be writing in an exam, you don't need to say a lot of things. Yeah, you just writing exactly what you need to write. But now me, I'm incorporating other factors because I know I have to take advantage of that to say as much as I can so that you learn, right?
Yes, sir.
Okay, draw the total fixed costs. TFC, by the way, is total fixed cost, and total variable costs, and the total cost on the same graph. Just need a graph. It's very easy. It's just a graph. It's like this. Okay. The total fixed cost is fixed like this. It's horizontal. Total fixed cost.
Okay.
It's horizontal. On the you should be able to label. Always the graphs in economics are labeled. You should know which one comes on the vertical axis and which one comes on the horizontal axis. Costs. Yeah. Then you have output here. So now, look at total fixed cost is horizontal. Then what about the variable cost? Right? What about the variable cost? So the variable cost will will start from down. Yeah. Then it will be increasing and increasing. Yeah. So let me just draw again so that it can be something. Let's see. Okay, like this. Total fixed costs, TFC, right? Horizontal. Then you have the variable costs that is moving like that. Okay. The variable cost is starting from zero is moving like this. Yeah. It's increasing with the level of output, in short. Okay.
Okay.
Total variable cost. Then what's this? The total cost itself, it starts from the total fixed cost up here. Let me write it in. That's where it starts from. Okay. It moves like this. This is the total cost itself. So the total fixed cost is born on top of the total fixed cost. Or the total cost here is on top of both the total fixed cost and the total variable cost. Because even by definition, the total cost is equal to total fixed cost plus total variable cost. Okay.
You said that the total cost is what?
It's fixed cost plus variable cost. When you add the fixed cost plus the variable cost, then you get the total cost.
Okay.
Right? So the total cost, basically, what is there with the total cost is that the total fixed cost. This is the cost that does not change with the level of output. Yeah, you can increase and increase output, but the cost just remains the same. You could give an example of rent, right? You are renting your building. Whether you produce zero output or you produce billions of output, obviously the rentals remain the same, right?
Yes, sir.
I don't know if there are some landlords who say now you're making more money in your shop, now we are increasing. Okay, this time around it seems people don't come. There are few people who come maybe in your shop. Okay, we can reduce the rent. Now we can increase. No, it doesn't work like that. Mostly landlords will just tell you, you pay this kwacha. It is up to you now to know that I have to produce more so that I'm able to meet the costs. Is that okay? That's about total fixed costs. The fixed costs do not change with the level of output. They are fixed. That's why they're called fixed costs. And the variable cost these change with the level of output. Okay? They
Yes, sir.
change with the level of output. With them, the more you increase the output, the more you increase production, even them change and increase in number. So basically, those are variable, the variable cost. Okay? Yeah. That has been answered and people are following the SAR. You can move on to something else. Draw the average total cost, average variable cost, and the marginal cost on the same graph.
Okay.
Yeah. So what is there is we have got the marginal cost. Now with the marginal cost, so it's U-shaped, right? Marginal cost is U-shaped. You already saw last time. Our marginal cost is U-shaped. This is
Yes.
our marginal cost. And then the average variable cost as well, it's U-shaped, but on top here. Then which one is this? The average total cost, the average total cost is on top of the average variable cost, right? It is on top like that. Then the average fixed cost, and let me write it in red, is basically asymptotic to the what's this? The x-axis. It's asymptotic like that. That's the average fixed cost. It's asymptotic. Then this one is marginal cost. Yeah. The marginal cost, sorry, cuts the, usually it cuts the, at the minimum usually. It cuts the marginal cost. This is average what? This is the average total cost, right? And this is the average variable cost. Like this is what we get.
Okay.
We have combined all the graphs now. I've put them on the same graph, all of them. The marginal cost curve, which is U-shaped, it cuts the average cost and the average variable cost at their minimum, okay? The average cost and the average variable cost, they are U-shaped, if you have observed. They are U-shaped, okay? Yeah, they are U-shaped. Clear?
I'm trying to understand these graphs.
Okay, yeah. Yeah, you will understand then. Because this is more like introducing a topic and we're talking about a topic. So yeah, you will understand. So what is happening is that the average cost curves are U-shaped. The average variable cost is U-shaped. The average total cost is always higher than what? The average variable cost. Because practically, you know that average total cost is bigger than the average variable cost, right?
Yes, sir.
Yeah,
Average.
the average total cost is higher than the average variable cost because the average total cost is coming from the total cost. So in short, we can remove, okay, the averages. We know that total cost is equal to fixed cost plus variable cost. That's what I said, isn't it?
Yes, sir.
So the variable cost is smaller than the total cost because the total cost is also the sum of variable plus the fixed cost. That's why you find it on a higher, like it's higher than the average variable cost. Because the average variable cost is just considering the variable cost. It doesn't consider the fixed cost as well. But the average cost or average total cost is basically the sum of the two. Did you get that?
Okay. Yes, sir.
Okay. I don't know if the others are following in the background.
Yes,
Am I moving so fast? Okay. No, the SAR is not moving fast. Okay, it's a good thing if it is not. So this is what is there. In short, this side you have costs, yeah, on the vertical axis. So this is how you put these graphs. You should understand this. That's why I'm recording this class so that I send it to you. You go through, understand these graphs, how they are put. Clear?
Clear, sir.
You know, with cost theory, the cost theory is just about graphs. It's just about graphs and some few numbers that you're going to see here, filling in the tables, just like that under introductory micro. So you don't really get into the deeper conversations. Yeah.
Okay.
Okay. So that the gap between the average cost and average variable cost is equal to the fixed costs. You have to show that the gap graphically show that the gap between the average total cost and the average variable cost is equal to the fixed costs. Okay, check this. It's basically almost the same graph. The average cost is this one, right? The average total cost, if you know, like, then the average variable costs, it is also like this, but it comes closer and closer as well to average. The average variable cost, it comes closer to the average total cost, but they never touch each other. They'll just be closer and they'll move parallel like that in the long run. Then the total fixed cost will be moving downward like this, coming horizontal, and will keep the same space, okay, the same size of space, the total fixed cost. The average fixed cost here is this one, which is sloping downward like this, which is asymptotic the origin. So basically, that's what is there. So the gap in between these two is just the same. The gap in between the two is just the same. Clear?
Yes, sir. Okay.
If that is clear, then consider the table below and copy into your answer booklet. So you are in an exam. Copy into the Unza answer booklet and start answering the questions that follow. You've seen the table that you need to copy into the Unza answer booklet. Yes, we have seen it, sir. So the question says, fill in the table with the values of total fixed cost, total variable cost, total cost, marginal cost, average fixed cost, average variable cost, and the average total cost. In short, we have to fill in the blank spaces. That's the message. Did you get the question? There is this table here. You have to fill in, okay, in short, the blank spaces. Yeah. So let's go. How is it done, Wasa? What we are given here, the first one is, observe that we are given the total fixed cost and the output in the first one. We need the total variable cost. We don't have the total cost. We don't have anything. We don't have nothing. So how do we find the variable cost? Yeah. So those are questions that you need to answer. So what you should understand is that the person will not need to panic because we know that, first of all, total fixed cost is what? Is fixed as the name suggests, right?
Yes, sir.
So here you have 300, even here you have 300, even here you have 300, and even here you have 300. Yes, we said it is fixed.
Oh.
That's what we said.
Okay.
Now, so what is there is that when output is 0 here, total variable cost, yeah, The total variable cost is found by saying variable cost times what? Times the output. That's the total variable cost. The variable cost times the output.
Okay.
So check. How do you so in short, the first line, this one, the first line, this one will just give you zeros because the output is the one that will contribute into the zeros of everything. Yeah. So what you do now, the second line, to get the total product, the total cost. How do you get the total cost? You have the fixed cost, you also have the variable cost. So you add, we say the total cost, this total cost, it is equal to total fixed cost plus total variable cost. That's what we said, right?
Yes, sir.
So it will be what? 380, right?
380, yes, sir.
Yes. Then when it comes to this one in the middle here, we know that we don't just have the variable cost, but we have the fixed costs. We have the total costs. We can subtract to look for the variable cost, this total variable cost. We can manipulate this equation. We say total cost minus total fixed cost, right? Is equal to the variable cost total. You're seeing the equation that we are changing?
Yes, sir.
Down here, yes. You get the total fixed cost to the other side of the equation. Then you saw that you can make the total variable cost the subject of the formula. So in short, you're subtracting from the total cost, you're subtracting the fixed cost. So total cost 400 minus fixed cost 300. What do you get? You get 100, right?
Yes, sir.
Yeah. So just understand this to my simple formulae. Yeah. To my formulas, Nikulemba, very important. Otherwise, there is nothing much difficult. Then when you come to the third one as well, it will be what? It will be 430, isn't it? 430, this one. It will be 300 plus 130. Okay, you are adding fixed cost plus total variable cost. You add together, that's when you get what? That's when you get the total cost. Yeah? That's what we've said in our formula. We said the total cost is equal to fixed cost plus the variable what? The variable cost. So you add 300 plus 130. Clear?
Yes, sir.
Okay. Then the last one, obvious again, is total cost minus fixed cost. So say 500 minus 300, that should give you 200 as
Yes,
the
sir.
total variable cost. So it's about playing with the equation. Like just understand this to my simple formula that I have been preaching. Then from there now, we can fill in these other columns that I've made, right? Yes, sir. Let's start from the marginal cost. How do you find the marginal cost? Is total cost 2 minus total cost 1 over output 2 minus output 1. It's just the same thing.
Okay.
So the second one in this will be 300 minus the 0, this one, divided by 1 minus 0, it will be 300 here, right?
Yes, sir.
Or it will be 380. Sorry, not 300, 380. 380. Like you're doing the second output here, it will be 380 minus 0 over 1 minus 0. So this will be 380, right? Then you will say 400 minus what? 400 minus 380. That gives us what? 20, right?
Okay, 400 minus 380, yes, it gives us 20, sir.
Yes, 20. And the 430 minus 400, it gives us what? 30, right?
That will give us 30, yes.
Yes. And 500 minus 430, it gives us what? 50. Okay?
You said 500 minus 430.
500 minus 430. Yes, you are subtracting the previous, the top one minus the previous. 500 minus 430. 500 total cost minus 430 divided by,
It will
or
give
is
us
it,
70, sir, not
it
50.
gives us 70. Okay,
Yes, sir.
thank you. Yeah, it's 70. Yeah, just like that. Okay, so we are done with the marginal costs. The marginal cost, you have learned the concept of marginal cost, isn't it?
Yes, sir.
Now we can bring you to the concept of average fixed cost. So average fixed cost simply means fixed cost, total fixed cost divided by output. Okay,
Okay.
that is the average fixed cost. These formulas are very, very important. Okay, should find time to listen to this. Average fixed cost is equal to fixed cost divided by what? Q, or output, right? So you say, you start with the second one, fixed cost 1 into 300, it will be
It's
300,
300,
right?
sir. Yes, sir.
And 2 into 300, 150.
To give us
3 into
150.
300, 100. And 4 into 300 is what? 75, right?
4 into
300.
yes, sir, 75.
75, like that. That's how you find the total fixed what? Total fixed cost. Then you go to average variable cost. Oh, the average fixed cost is found like that. Then the average variable cost, AVC, average variable cost, it is actually total variable cost divided by what? This total variable cost divided by output Q. So you are dividing into the variable cost, right? So the first one is 1 into 80, it gives us 80, right?
1
The
into
first
80
variable cost, yes. Yeah, then 2 into 100 gives us 50, right?
Yes, sir.
And the 3 into 130 is what?
13.
3 into
130 divided
130.
to give us 43.3.
43.3. Then the next one is 4 into 200, that's 50, right? That's average variable cost. Okay? Yeah.
Okay.
Then again, when you go to, we say the average variable cost, it is what? It's U-shaped. Just from the graph, the way how your graphs were performing, if you want, like if you want to just take a look, a closer look to the way how I drew the graphs. You understand that the total fixed cost, I drew it like this, right? This is how I drew it. The average fixed cost. Because it starts from up, then decreasing and decreasing and decreasing and coming closer and closer like that as output is increasing. So check, it starts from 300, it's decreasing and decreasing and decreasing and decreasing like that, right?
Yes, sir.
Yes. Then the average variable cost, I said, is U-shaped. If you remember the way how I drew it, the average variable cost, it was U-shaped, and it was inside this was the AVC, the average variable cost. Why U-shaped? Meaning it starts from up, it decreases, again, it starts increasing, which is true. It started from 80, 50, 43, again, 50, is going up again. So that's a U-shape that it depicts, just as the graph showed, okay? It starts from increasing, then it decreasing, starts from up, it is decreasing, then again, it starts increasing. You see, which is exactly the same the behavior that is depicted by the graph. Okay?
Yes, sir.
Then when you go to, what's this? Total variable cost. Now, this one is just total cost divided by what? By output. So you're dividing total cost divided by output. Total cost, 1 into 380, it will be 380, right?
380, yes, sir.
Yes, 2 into 400, it will be 200.
200.
And the 3 into 430, so what?
You said
3 into 430.
to give us 143.
143.2. Then you say, okay.
0.3.
So now 4 into 500.
500 divided by 4. 125, sir.
Sorry?
120, 125.
120, 125. 125. Yeah. So even this one is decreasing and decreasing, but again, as output will be increasing, you realize that it will start increasing with some time again, just as the shape was shown by the graph. Okay?
Yes, sir.
Yeah, it doesn't move zigzag that it goes up, it goes down. There is consistency in the behavior of numbers. So you can see that now these numbers, the way how they have behaved, it is exactly the same thing that we talked about on the graphs. Like they are depicting the same behavior that you show in the graph. Increase, then decrease, increase. Like that, those that should depict the U shape. Right?
Yes, sir.
Yeah. Then the average total cost, it starts from up, it will be decreasing and decreasing. Then the rate at which it is decreasing will start reducing with time. So check the first one, it was all the way from 300 to 150. Then there from 150 to what? To 100, right? I'm talking about the average fixed cost. The average fixed cost. Then from 100 to 75. You've seen that it is decreasing. First, it is faster, then it is slowing down. It's slowing down in terms of its decrease. So it's almost becoming constant, right? Yeah. Check it. The first difference was 150. The second one was what? Was 50. Then the third one is what? Is 25. So it's decreasing and decreasing until it becomes constant. When it becomes constant, this is the time when it will become asymptotic to this original line. It will become like this, almost as it comes closer to some output down here. It will become almost how would I say, parallel to this line, which means it becomes constant. Okay.
Yes, sir.
Yes, that's the behavior. Any question?